Is it recording now? All right. Who attended my last lecture? Raise your hands. So there are some new admissions. So I think you are attending my first lecture. Who else? Everybody else. What about you? You.
I've attended.
Yeah. Okay. Oh. So tell me, where did we stop in the last class? We were doing motion, right? अरे हाँ ना बोलो भाई. So we had started with graph. Camera on नहीं है? अच्छा. So graphical representation of. Okay. So we are already familiar with about what in this chapter. What have we discussed so far? We have talked about what is motion. Okay, we have talked about what is rest. Right? Everybody knows about it. Then we have talked about distance. We have talked about displacement. Then we have talked about what? Speed, velocity, okay, acceleration, retardation, and retardation, right? What else have we discussed? We have discussed speed and average speed. Velocity and average velocity. Have we discussed about instantaneous velocity? We have speedometer and all. Have we talked about odometer, speedometer? We talked about it, right? So what does the odometer gives you?
So the distance covered by
The distance covered. What speedometer gives?
the speed covered.
At that moment. That is called instantaneous speed or instantaneous velocity. What else have we covered? Okay, so we have covered this part. And now, so any doubt in this? Anybody?
Sir, can you please refer this?
Displacement is the shortest distance. Suppose an object is moving from A to B, right? So it can take various paths. It can go like this, or it can go like this straight, or it can go like this. Okay, so 3 paths are possible. Okay, different routes, different paths. So what is displacement? The one with the shortest distance. Okay, so it is only possible if it moves always in one direction. So displacement is shortest distance between 2 points. Shortest distance in a given direction or in a specific direction. Right? Whereas here, if you see, the direction is changing all the time. Right? Direction is not specific. Okay? Yes. If take the attendance sheet, those who entered. So this is displacement. Any other doubt, anyone? Okay, so I think we have done a very detailed discussion on everything and done some numericals also. Have we? Okay. So today we'll do this graphical representation of motion. See, when we study motion graphically, it becomes even more easier to verify, right? Have you also studied uniform and non-uniform motion? Uniform motion and non-uniform motion. Have you studied about it? What is it? What is uniform motion and what is non-uniform motion? Yes, is uniform motion. Non-uniform mein unequal distance is covered in equal interval of time. So what is constant in uniform motion? There is something which does not change. The rate of motion, velocity. So the rate of motion. So V is equal to constant. Okay, in uniform motion, what is constant? The rate at which the distance is covered. What is rate? Displacement upon time. Okay, what is V? Displacement upon. So S by T, right? What's the formula? S by T. So S is same for every 1 second. That's what it means. So it is S by T, right? S1 by T1 is equal to S2 by T1 is equal to so on and so forth. Where T1 is equal to T2 is equal to 1 second always, and S1 is equal to S2 is equal to S2, so on and so forth. So time is 1 second and distance covered is equal. Okay. That's what is uniform motion. Let's represent a uniform motion. So what kind of graphs are there? There are so many graphs. One is distance time graph. Time graph.
Yes.
Okay, so distance time graph for two types of motion. It is uniform motion or uniform motion. Okay, so what is distance time graph for uniform motion? So it should be a straight line graph. It is in seconds, right? So what do we have for this? Suppose you have 1 second, 2 seconds, 3 seconds, 4 seconds. Every interval is 1 second. Let us say it covers the distance as 5, 10, 15, 20. So what is the distance traveled in first second? How do you draw? You draw dotted line parallel to x and y axis. So what was the distance in 1 second? 5. The intersection will give you, that is 1 second, 5. 2 second will be 10 minutes. 3 second is 15, right? Is 15. 4 second is 20. So if you plot the graph, you'll get straight line passing through origin. Okay. So what are we seeing? See, every interval is 2 minus 1. How much this? Is this 1 second? And what is this? 5. 10 minus 5 is 5, right? So what we do is if we extend this line, we get this triangle, right? We get a right angle triangle, right? So if you take any two positions, let's say this is A and B. Okay. So in this time interval, how much displacement was covered or distance was covered? This much. So the perpendicular of the triangle gives variation in displacement or distance, and the base of the triangle gives variation in time. So I can also say this as S2, this as S1, and I can say this as T2, this as T1. So what is this then? This is S2 minus S1. And this is T2 minus T1. Correct? What is S2 minus S1? This displacement. And T2 minus this one is this time interval. So what is this ratio? S2 minus S1 upon T2 minus T1. What is it? The distance covered in the given time interval. So what is it? Is it speed or is it velocity? For distance time graph, it will be speed. If it was displacement time, so it could be distance or displacement. Okay, anything. If you have plotted displacement time, then it will give you velocity. If you have plotted distance time, it will give you speed. Okay, this is nothing but speed. Clear? So this thing, the change in y-axis divided by change in x-axis, we call it slope. What do we call it? Slope. Slope. You will study about it in mathematics. What is slope? The variation or change in y-axis divided by change in x-axis. X-axis. Okay, it is represented as y2 minus y1 divided by x2 minus x. So what is y2? Final value. So if you're starting from origin, so with time, right? This is initial t1 is initial time, t2 is final time. Likewise, s2 is final distance or displacement, s1 is initial. The difference. So it is always final value minus initial value. For any chosen 2 points on the graph. Where are these 2 points? On the graph. Clear? So is the concept of slope clear? So slope of distance time graph gives speed or velocity if it was displacement time graph. Okay? Right on. The slope of distance time graph gives speed. Sorry.
So we have already.
ये लिखा दिया है क्या मैंने? अच्छा. Slope करा दिया था क्या? Somebody show me your. So next is acceleration time. So is it uniform motion? Is this uniform motion?
Yes, sir.
Why? Straight lines. है ना? So non-uniform motion भी कराया था क्या? क्या बनाया non-uniform? हाँ ये भी बनाया है. सबको करा दिया है मैंने. चलो ठीक है. तो ये मैं मिटा रहा हूँ. Because you have already done it. So those, I think only you are to write. So you can borrow the notes and write it. Okay, so just identify what graph it is. ये भी बता दिया क्या? ये भी बताया है. बताओ what graph it is, and the fourth graph is next graph is
Is distance.
all are distance time. These are distance time.
First is uniform motion.
Correct. Very good.
Second is non-uniform motion.
And why? This is uniform motion. Everybody understood it? Straight line means it is covering equal distances in equal interval of time. Okay? Now, just by looking at the graph, this is non-uniform motion. Why? Therefore, take equal time interval. Okay? 1, 2, 3, 4. How much is the displacement covered in the first second? This much. In the second, is it same? This is in the first second. Second. Is it same or increased? Increased. Now you got the benefit of graph. If same time interval, now we are getting different distances covered. So curve gives non-uniform motion. Okay? Non-uniform motion. What about this? Object at? So whatever is the time is changing, right? For all times, displacement or distance is not changing. 5 and 15 by. Is it changing? No, right? So this says object at rest. Okay. अरे ये 2 बार हो गया. चलो अब मैं तुम्हें एक और देता हूँ. This is for two objects A and B, whose speed is more, who is traveling at a faster rate, A or B? B. Why B? Why B is traveling at a faster rate? Why A is traveling at a faster rate? Yes.
So because the time covered is less.
Time covered is less. Exactly. Suppose you take any common displacement. Is this displacement common? A takes this much time. B takes, which is greater? B is greater time. So to cover the same distance, B takes more time. A takes less time. So who is fast? A or B? Understood? So in slope terms, jiska bhi slope is steeper. Can you see? The slope is less. Slope is angle with the x-axis. So here the slope is more for A. So for the graph where the slope is more, that is faster. ठीक है? तो भी समझ में ग्राफ से कैसे क्वेश्चन आंसर करते हैं? So A speed A is greater than B. Speed of A is greater than speed V. समझ आया? What is this graph representing?
Speed is decreasing.
Speed is decreasing. Speed is decreasing. What is this graph about? Distance time. So, what is happening? Distance is in the opposite direction. Here, if the object, let us say, these are the two positions, right? Origin, and let's say it is going from O to A. In this case, it is going away. This is the starting point. It is going from O to A, for example. What about this? This is going from A to O. So graph tells you direction also. Okay, समझ आ गया? Okay, so with this we are done with all the distance and graph. Okay. Next is, so what is it? Object moving in opposite direction. Towards origin. Origin. Okay. That is opposite direction. Okay, so you might want to copy these two graphs. I think I've done till rest. Okay. So copy last two graphs. What do they represent? Object A is traveling with a faster speed than object B. Object moving back towards origin. When is it coming to origin? At this time. So this is 1, 2, 3. It's 2.5. Roughly 2.3 seconds. What do we cancel it? Should I erase the upper three graphs? This is 1.5 hour lecture, right? 90 minutes. So velocity time में y-axis we will draw plot velocity values and x-axis पे time values. Which is we must we'll discuss what these represents. We written it down. Sure. Forward motion in the First graph representing. Raise your hands. Object is at rest. I was expecting it. Why object is at rest? Is object at rest? Yes. How many for object at rest? 1, 2, 3, the whole class. What is this graph about? Velocity and time. Is the velocity 0? For the object at rest, what should be its velocity? 0. What is the velocity? What is the velocity in the graph? 15. Means object is moving at the rate of 15 meters per second. Every second, object is moving by 15 meters. So how is it rest? Okay? So this is about graph. You have to be careful. If it was a displacement time graph, is it a displacement time graph? No. In a displacement time graph, is the displacement changing? Or is the distance changing? No. Distance is whatever it was. If it was 15 meter, it remains at 15 meter. What is this? Meter per second. So this is rest. This is uniform motion. Why? V constant. In uniform motion, what happens? Velocity is constant. So this is uniform motion. So it depends on the question. So read the question carefully. If the question says draw the graph for uniform motion, velocity time graph for uniform motion, we'll draw this. Okay. Now what's this graph? Is the difference clear in both the graphs? This is not at rest because velocity. What is uniform motion? V constant. That's the definition. So what does it mean? It means for any object, if its velocity is constant, then it is in uniform motion. Every second it is covering same distance. What is the slope of this graph? What is the slope? Did you write when I said what is the slope? Change in y-axis divided by change in x-axis. So what is the change in y-axis here? I was nervous. See the graph and tell me. Is y-axis changing? So what's the change? No change. No change means 0. Is there any change in the y-axis? No. 0 divided by anything is 0. So slope of this graph is 0. Obviously, I said what is slope? It is the inclination with respect to x-axis. Is there any inclination? Huh? Where? So this has slope because it is making some angle with x-axis. Is it? Is this making any angle with x-axis? No. Slope is 0. Which means what is 0? So first let us find out what is the slope of VT graph. What does it give? So I told you how to calculate slope. You calculate change in y-axis. So what does change in y-axis represent? Change in velocity. What is change in velocity? 15 minus 5. 10 meter per second. That is a change in y-axis. What is the change in time axis? So it is T2 minus T1. What is T2? T. So what is the change? T minus 1. 2 seconds. So what is the slope now? Slope is V2 minus V1 upon V2 minus E1. What is it? N by 5. 2 meter per second. So what is this 2 meter per second square? This is velocity in meter per second. This is time second. So when second goes up, what unit will you get? Are you familiar with this unit? It is unit of acceleration. So slope of VT graph gives acceleration. Okay? So therefore acceleration. This is nothing but acceleration. Rate of change of velocity. Then isn't it changing velocity? V2 minus V1 on time interval. What is changing velocity upon time interval? Acceleration. So what did you learn? Slope of VT graph gives acceleration. Whereas slope of distance time graph gives speed. Is it clear? This is the conclusion. Okay, second. Area under VT graph gives displacement covered by the object in given time interval. Okay, these two information we get from area under VT graph. Let's verify. So from this graph, what do we see? Silent please. Suppose I ask you a question, right? How much displacement is covered by the object between 2 and 3 seconds? Will you be able to answer? How much between 2 and 3 seconds? So basically 15, right? How do you know? E is equal to S by T. Therefore, S is equal to V into T. Since V is not changing, it is always 15. And between 3 and 2, what's the interval? 1. So it must be 15 meter. Isn't it? So let's find this area. What is this interval of time? 1 second. And what is this? 15. So for this rectangle, 15 into 1 is 15. Isn't it? So you can see when you take the area under VT graph, you always are getting displacement. Okay? So if I ask you how much displacement is covered by the object in 4 seconds, find out from the graph. Now it will be the area. 15 into 4. This whole area. So this is 4. And this is 15. That is 60, right? So S is equal to 15 into 4, which is 60. Okay, so area under VT graph gives you displacement. Very important. Okay. So what is the nature of motion? All straight line will have constant slope, whether I am taking slope over here between 2 points. So I can take slope between these 2 points also. Will the slope change? Slope is the angle. Is the angle changing with the x-axis? No. So I take any 2 points on a straight line, slope will always be same.
Sir, can we take 10 instead of 15?
Yeah, you can also take 10, but not with the same graph. If the graph was this, then you get.
So not with that.
How? It is given, no, 15. How can you take 10? What is changing is only time. Is the velocity changing? No. Velocity is always 15. Clear? Yeah. So anybody has any question can ask. Only thing remaining is slope for any straight line will be constant. So you can choose any 2 points. For example, now what is the time over here? This is 2. Time over here is 5. So 5 minus 2 is 3. This is 3. What is this? 20. No, this is 25, right? Is it 25? Right? So how much it is? 25. What is it? V2 minus T1. And divided by T2 minus T1. The slope. Okay, what do you expect? Five minus 2 is 3. Wrong. What is wrong? Every second, how much velocity is changing? 5. So इसको साइलेंट करो भाई. Is 25 minus 10, right? 10. So where did we take? 3 का लेना. हमने कौन सा point लिया है? What 2 points we have taken? ये वाला लिया है और ये वाला लिया है ना. So यहाँ पे क्या इंटरवल है? 25 minus 10, and this is 5 minus 2. 5 minus 2. 5 minus 2. So 25 minus 10 is 15. 5 minus 2 is 3. So क्या हो गया? 5 मीटर. ठीक है? Are we getting 5 मीटर? ये देखो. यहाँ पे क्या गड़बड़ हो गया? T2 minus T1. T2 minus 2. This is 3 minus 1. 2 आना चाहिए. 5 लिखा है. किसी ने point out नहीं किया मुझे. How much is T2 here? For this case, T2 is 3. 3 minus 1. This should be 2. Should have been 2. So this will get 5. So 5 meter per second squared acceleration. Acceleration is constant. Is it clear?
So in this same question, can we take a point as 10 and the other point as 5?
Can we take the, yes, you can take any 2 points you take. Slope always will be constant. You can try it yourself. Because for a straight line, slope has to be constant. Here. And what does the slope indicate? Acceleration. Slope of VT graph gives acceleration. Okay. So write down. So what is the nature of motion? Straight line. Huh? Non-uniform. Yes, it is non-uniform. Why?
Because,
Displacement is going on increasing, right? Because it is accelerated motion. So non-uniform to hai, but is there anything uniform in this? What is constant in this? Slope is constant. And what is slope? So it is uniformly accelerated motion. What motion it is? Uniformly accelerated motion. Uniformly accelerated. It is non-uniform is correct. What is uniform? Acceleration. What is constant is acceleration. That is uniform. Okay. Uniform means constant. Something has to be constant. What is non-uniform? V, because it is changing. V is constant in this? No, that's why it is non-uniform. Got it? Yeah. So any questions still? So I'll give you now two graphs. First you write it. So what you need to write from here is just write down the graph. Okay, take one example of slope. This one. Then go. Slope is constant for straight line. So if it is a distance time graph, velocity constant. If it is a velocity time graph, acceleration constant. Am I going too fast? Please let me know. Should I erase this? Is right? Very good question. Right. हमारे टेक्स्ट बुक में शायद स्लोप वर्ड अभी यूज नहीं किया, ठीक है? स्लोप यूज किया क्या? कहीं पे नहीं है ना स्लोप, बट यही है स्लोप, मतलब ये जो हम वेरिएशन, इट इज वेरिएशन इन y एक्सिस विद रिस्पेक्ट टू वेरिएशन इन टाइम एक्सिस. मैथ्स उसको स्लोप. What is the nature of motion for this graph? So there are, the motion is divided into 4 time interval, 0 to T1, T2, T3, T4, right? Or OA, AB, BC, C. Okay. So बताओ, what kind of motion is this? Is it uniformly accelerated motion? Is it uniformly accelerated motion? No. So first of all, what is it? It is a VT graph. Uniformly accelerated नहीं है तो कैसा है? Non-uniformly accelerated. क्योंकि स्लोप एक्सेलरेशन देता है, ठीक है? तो अभी एक्सेलरेशन यूनिफॉर्म है क्या? नहीं, नॉन यूनिफॉर्मली एक्सेलरेटेड मोशन. पूरा टाइम यहाँ से यहाँ तक लेंगे तब for the entire motion is from O to A to B to T, O से D तक acceleration. Okay, it is non-uniformly accelerated motion. That's the nature of motion. Tell me, what is its nature in going from 0 to O to A? What is happening? Is it positive or negative? Positive. Why positive? Because V2 is greater than V1. If V2 is greater than V1, we'll get the answer as positive. T2 is always greater than T1. So time keeps on increasing. So it is positive, right? So acceleration positive. What about this? So at lesser time, you had a higher value of V. At later time, the value of V is less. So in this case, this is V2, this is V1. Is V2 greater than V1 now? No, because time keeps on increasing. Right? You can see this is T2 and this is T1. T2 is a greater value, but V2 is not. So we are getting negative. When acceleration is negative, what do we call it? Retarded. Okay. So in this graph, from O to A, body is accelerating. Then the body is retarding. Has the direction of motion changed?
Yes.
Why? Has the direction of motion changed? Anybody from girls side? So I am riding the cycle in this direction very fast. Now I apply brakes. My direction reverses. What happens? It just slows down. So negative acceleration does not mean change of direction. Negative velocity means change of direction. Got it? Negative acceleration means you are only slowing down, but you are continuing in the same direction. Okay? Then again, B2C is accelerated motion. Okay? And C2D is, so this is a positive. When the slope is like this, we say it is positive slope. When the slope is like this, we say it is negative. Why? I just told you. Why. Clear? V2 is less than V1. So when V2 is less than V1, it will be negative. V2 minus 2. Right? 3 minus 5. What is it? Minus 2. So if numerator is negative, answer will be negative. Is it clear? So with this, we are through with the graphical representation of motion. What kind of graphs did we learn? Distance time and velocity time. So what do distance time graph gives you? Nature of the motion, like uniform or non-uniform. What is the slope of distance time graph give you? Speed. What does the slope of velocity time graph give you? Acceleration. Okay. So when the Graph is straight line. In case of VT graph, what is the nature of motion? Uniformly accelerated. Okay. And when the slope is negative, what does it mean? Retardation. What is the area under velocity time graph? Displacement covered in the chosen time interval. Written over here. Have you noted it now? No? Can I erase it now? Any questions? We are done with graphical representation of motion. Okay, so when the numericals come, we'll see further. Now, using graphs, let us define the equation of. Or let me give you one question before we proceed further. Okay, this is P. So this is some kind of okay. I want you to find out what. Find the displacement of an object between 2 and between 2 to 4 seconds. Draw the graph. Take 1 centimeter as 1 unit on both X and Y. X 1 centimeter is 1 second, right? Just time. Here 1 centimeter is 10 units. Everybody is familiar with graphs. Everybody got there? So in a VT graph, how do you find displacement? What method do you adopt? Yes, how do you find displacement in VT graph? What is the method? Did I not teach you just now? At least tell me the method. What gives displacement in VT graph? The area under the curve, right? What is the area under the curve between 2 to 4 seconds? What will you do? You will draw these lines. Okay. So this is the trapezium you are getting, right? This is the trapezium. So what is the area of trapezium? Or you can find out area of this triangle plus area of this rectangle. Right? Let's name it A, B, C, D, E. So S is equal to area of triangle BCD plus area of rectangle ABD. Okay. What is the area of this triangle? So what is CD? How much is CD? 40 minus 20. So 40 minus 20 is equal to 20 meters per second. So V is V2 minus V1 is 40 minus 20 equal to 20 meters. That is CD is equal to 20 meters per second. And what is the base? Base is 4 minus 2. This is E2 minus E1. How much is this equal to? 4 minus 2, which is 2 seconds. What is the base? AE or BD? BD कितना हो गया? 2 seconds. What is the area of the triangle? Half base, half BD into height CD. 1 by 2 into BD is 2, CD is 20. So, and plus, what is area of rectangle? So, how much is this part? DE. Twenty minus 0. Okay. So what is area of rectangle? BD into DE. How much is BD? 4 minus 2 is equal to 2. D is again 5. So 16. You understood? You might get these kind of questions. Everybody understood what I have done? You can verify it whether you get the area of trapezium also the same thing. Anybody remembers what is area of trapezium? Also.
1/2 into height into sum of the parallel sides.
Also, S is equal to area of trapezium. Trapezium. It is called trapezium, right? Trapezium. What is it? A, B, C, E. Which is equal to, what is it? Area of trapezium? Half
Into the sum of parallel sides.
half into height. Height is BD, right? Sum of parallel sides. What is sum of parallel sides and what is height? Height is BD into what is parallel side? AB plus CE. You can write down straight away half into what is BD? BD is 2. How much is AB? AB is 20 plus CE is 40. Plus 46. So as long as you can calculate the area, you'll always get displacement. So either you find the whole area of trapezium or divide it into rectangle and triangle. Here. So these are the two methods I have given you to find the same answer. Okay. Now there is a reason why I gave you this, because next we are going to do is I think second last talk. Equation of motion by graphical method. Right? We just derive using this. We don't write. Okay. Next topic is derivation of variations of motion by graphical method. What are the three equations of motion? Do you remember? What is the first equation of motion? V is equal to U plus AT. S is equal to UT plus half AT square. The third is V square is equal to U square plus 2AS. These are called three equations of motion which give relation between velocity and time, position and time, okay, and velocity and displacement. This, what is the first equation? VT relation, velocity time relation. This is displacement time relation. This is velocity and displacement. Three different types of relations are there, which we call equations of motion. Can I erase this part now? Anybody is still writing this? We are going to consider this graph. Consider the following graph. Following VT graph. Time will be here. Okay. So now the graph is like this. So this is the time axis. This is the velocity. Velocity on y-axis, time on x-axis. Let's say this is equal. These are the 2 points of the velocity curve, u and v. U is the initial velocity and v is the final velocity. So where is v? Okay. So at time t, we have initial velocity, and at time 0, we had u. Correct? These are the 2 points on the graph, u and v. On the y-axis, the 2 point on the time axis is this. Okay. Now let's name it. Let's name it. So this is a trapezium, right? Let's call it O. This has A, B, C, and D. So first, derivation of PT relation, velocity time relation. So from graph, acceleration, A is equal to. How do you find acceleration from VT graph? We take the slope. So what is A? So G minus U divided by T minus 0. Right? So minus equal to T or it is equal to G minus U. That's the first level. Before this class, how many classes we have done? 4, 3 or 4? 3 only. Just check on whether it is 3 or 4. Maybe 3. So today is 4.5. So any difficulty in this? Straight away from the knowledge of slope of VT graph, we found this. Next, we want to find out ST relation. Second will. Have you written? Everybody is written clear? I'll just modify above. Displacement time relation. So from graph. Displacement. Yes. How do you get displacement from VT graph? Area under VT graph, right? Area ABC plus area ACDU. Correct? So area of triangle plus area of rectangle. So how much is this? What is area of triangle is equal to? Half base into height, half AC into AC plus AC into CD. Correct? Understood? So you can write area of triangle ABC and area of rectangle ACD or whatever. What is AC? T minus 0. Right? AC will be, what's the value of T from X axis? T minus 0, that is T. And what is BC? What is BC? BC is B minus U. AC is B minus 0. Okay, so change in y axis, upper value minus lower value. Here, upper value minus lower value. What's this? This is T2. This is T1. Where is it starting from? What's this value? T on the x-axis. Right? On time axis, what is this value at D? T. So we are finding out what? What is AC? AC is same as OD. AC at on time axis, what is C? Same, no? C and T same. But on y-axis, CD is U minus 0. C and D on x-axis are same. Right? But on y-axis it is U minus 0. What is it? Right? DCB is T only on x-axis. They are different on y-axis. D, U, and C. You know graphs, right? how to work with graphs. This is the point. What is its x coordinate? T of point B. You write it as xy, right? What is x for B? T. What is y for B? B. You know this, right? Ordered pairs. And here, what is it? X is 0, y is u. Yeah. It's the same mathematics that you know. So now when I'm asking AC, what is AC in the diagram? AC is this on x-axis, which is T. Okay? All right. Say it loud. Yes, sir. No doubts. Okay. So AC is T. What is BC now? You tell me. What's BC? B minus U. So write B minus U. Again, AC is T. What is CD? U. Everybody gets me till here? I'm waiting. Will you give me a go ahead? Each one of you got it? How I got all these values? Now just simplify. So this is 1 by 2. T minus 0. So it is T minus U plus UT. I'm just rearranging. So half into dt minus half ut. ओके ये नहीं करने की जरूरत है एक सेकंड what is half t? What is v minus u from equation 1? V minus u is 80. Plus, now we will rearrange ut plus half 80. Why? What we use? Since v is equal to u plus 80, therefore v minus u is equal to 80 from equation 1. So we substituted it over here, v minus u. You're doing it for the first time, so you may take a little time. Derivations. First equation of motion, what was it? You already derived it, right? So v minus u is equal to 80. So we substituted for v minus u as 80. Correct? यहाँ पे एक कॉमा दे दो हम ग्राफ yes. Have you all understood this? सारा खेल ग्राफ में और जो उसके पहले का एग्जांपल पढ़ाया था अब हमारा थर्ड इक्वेशन बच गया be able to do third equation. Are you comfortable till here? Why are you smiling? Because it is so easy. It is easy actually. First time it looks little different. Once you become familiar, Go home, revise it and introduce. Next. सबका लिख के हो गया सबका? Now derivation of position and velocity relation. Yes. Actually, we don't say V because it also has another velocity U. So you'll say velocity displacement relation. What is it? Velocity displacement relation. This is displacement time relation. Okay. This is velocity time relation. Because you have two velocity, initial and final. Okay. What will you say? Just write down. Since there was no space, I just used the symbols. It is velocity time relation. It is displacement time. It is also called position time. Displacement is change of position. So this is also called position time relation or displacement time relation. This is called velocity position relation or velocity displacement, whatever. Let me derivation of, if I say S, velocity time relation, VT, velocity time. What is the third one now? Velocity position. In your book, it might be given as velocity position relation, right? Am I right? Have they given displacement or position? Position. It's okay, position velocity, because here whatever comes on y-axis, we write first. So position velocity relation is same as velocity position between the two. Okay. Let's go ulta kar do, it's okay. It doesn't matter. So what matters is what we are going to do now. So also displacement equal to area of trapezium. Which trapezium we have? ABCDO. Okay. So what is this area? Half sum of parallel side into distance between them. So half AO or OA plus DB into AC. AC or OD will accept AC. Correct? Enough? So AC is the distance between the parallel sides. And OA plus DB are parallel sides. So what is OA? U. DB is D to B is full V. And what is AC? AC is B. Okay.
So how is that whole B?
How much is this from here to here? This DV. What's this value from origin? B, right? Everybody is floating. But just think about it. If it is not clear, I'll explain again in the next class. So don't worry. Huh? Don't worry. So what is this? 1 by 2. What is T? T from here is B minus U upon A. And this displacement is S. Correct? So since V is equal to U plus AT, therefore AT is equal to V minus Q. Therefore T is equal to V minus U upon A. So you have just eliminated T. Every time we are making use of equation 1 to make some changes in displacement equation. Previously we used B minus U equal to 80 to derive this equation. And to derive this equation, we are eliminating T by use of first equation. So now you just rearrange. So 2 and A in the denominator will come here. B plus U into B minus. So what is A plus B into A minus B? Right? Hence, A plus A minus A square minus B square is? Yes. See, you know it already. So just rearrange. So this is equal to B square plus. Okay, so we have derived all the three equations of motion by graphical method. If you want, you can write position for position, time, position, velocity, velocity time. Is it clear? Wonderful. So just one more topic remaining in this chapter. Next class we will be able to finish that. Okay, that topic and okay, so I'll clear in the next class if there are.